Thank you. Good afternoon. My name is Eva, and during our meeting today, I would like to talk about forecasting. Forecasting as a very sophisticated part of the data science. But I will try to do my best to keep this talk clear and accessible for everyone. As we all know, forecasting is difficult at the best of times, and in many cases is more of an art than a science. The key word for my presentation today is forecasting. So let me start with a definition of it. Forecasting is defined as a predicting the future as accurately as possible, given all the information available, including historical data and knowledge of any future events that may impact the forecast. There is a family of popular humorous sayings about the formidable task of successful prognostications. Here we have 5 examples. These expressions have been attributed to diverse collections of individuals, so to the Niels Bohr, Mark Twain, and so on. But I think that from the large family of this saying, at least 2 are worth citing. So the first is President Eisenhower's truistic observation that the future lies before us. The second has been variously attributed to Mark Twain and Yogi Berra. It is dangerous to make forecasts, especially about the future. And how these quotations serve as a warning of the importance of finding a good model and the difficulty to find a model that correctly identifies those futures of the past data, which will be replicated in the future. In other words, forecasting is certainly a tricky business. However, forecasting has fascinated people for thousands of years, sometimes being considered as a sign of divine inspiration, and sometimes as a criminal activity. An example, by 300s BC, people needing forecasts would travel to Delphi in Greece to consult the oracle. On the other hand, forecaster had a tough time under the Emperor Constantine, who issued a decree in forbidding anyone to consult soothsayer, a mathematicians, or a forecaster. And he stated, "My curiosity to foretell the future be silenced forever." Similar ban on forecasting occurred in England in 18th century, when charging money for predictions became a criminal offense. And the punishment was 3 months imprisonment with hard labor. So no doubt, forecasting is one of the common human behaviors in the entire human history, and never lost its popularity through the ages. Unlike any superstitions or prophets' visions about the future, forecasters try to light uncertainties with possible outcomes, which helps to change the world of uncertainties to the world of opportunities for the decision maker. Now, probably I should say something about the origin of predictive analytics. So the origin of predictive analytics dates back at least as far as modern statistics itself. But it wasn't until the 1950s that various organizations began using computer-based modeling to anticipate everything from weather patterns to credit risks. So let us now ask a very simple questions. Why do we make forecasts? The answer is to make predictions. To make predictions about the values of variable, to make predictions about an outcome, and these predictions are intended to guide decision. But the next question is, what does it mean a good forecast? And when we can think about a number of characteristics that are common to a good forecast. So good forecast should be cost-effective, easy to use, easy to understand, reliable. But I think the most important is that a good forecast should incorporate all available information and be as accurate as possible given these informations. It should be also timely, which means it should be development early enough to inform adequate planning and allow sufficient time to adjust accuracy. In other words, a certain amount of time is needed to respond to the forecast, so the forecasting horizon must allow for the time necessary to make changes. A good forecast is assumed to be one that is equal to what actually happened. But forecasting should never be confused with prophecy, because the chance of forecasting the exact value of random variable are almost zero. For many data scientists, forecasting is both an art and science for predicting what will happen in the future. So let us now concentrate on the scientific aspect of forecasting. So forecasts come from statistical methods and powerful computers. Usual refers to quantitative methods. And these quantitative methods help us to identify the existing relationship and establish patterns. However, they almost exclusively assume that the future is like the past. So forecasting, however, is not only a science, it's also an art. So as an art, forecasting is using judgment, what many people refer to as the gut instinct. However, like quantitative methods, relying on the judgment alone can be determinantal. Therefore, the ideal solution would be to use an approach that merges the science, means quantitative methods, with an art, means the forecaster insight, knowledge, instinct, intuition, and so on. In the other words, inspirations exist, but it has to find you working. And this leads me to my next point, which is pollen forecasts. Let me start with a trivial questions. Why do we need a pollen forecast? The primary use of the pollen forecast is to enable those who suffer from pollen-related difficulties to take steps to protect themselves from the consequence of the high pollen level. But we must remember that pollen count and pollen forecast, it is not the same. So pollen count is the amount of pollen per cubic meter observed during the past 24 hours. Whereas pollen forecasting is the predictions of the anticipated atmospheric pollen concentrations over a short or long period of time. Pollen forecasting required knowledge of aerobiology, meteorology, climatology, plant phenology and plant ecology, and data science. In other words, in order to begin our journey through forecasting, we should first define the problem. Then collect the data needed to inform our model. Next, prepare the dataset. Explore the data and plot the data. Next, we can try to build a model. When we have a model, we need to validate it. And in the end, when we already have a model that is working, we need to constantly monitor its effectiveness. Model enable us to make a forecast, and forecast can be classified as short-term, medium-term, and long-term. Short-term forecasts involve predicting events only a few time periods into the future. Medium-term forecasts extended from 1 to 2 years into the future, while long-term forecasts can extend beyond that by many years. In case of pollen forecast, we usually have short or long-term forecast. And short-term forecasts address day-to-day changes of pollen levels. And during the pollen season, these changes largely are governed by daily weather conditions and need to be updated daily, or let's say every few days. In case of long-term forecasts, it addresses possible trends in seasonal pollen levels caused by, for example, climate change or like big forestations and so on. And they generally required an observational data set from monitoring carried out for many years in a given area. There are few approaches used to handle the task of making a pollen forecast. The selections of methods depends on many factors. The context of the forecast, the relevance and availability of historical data, the degree of accuracy needed, the time period, the cost, the benefits, and the time available for making the analysis. And we have like observations-based model, regressions model, time-series modeling, and a model based on artificial intelligence. So let us now concentrate on observation-based model. In short, we can say that this type of modeling rely on the visual examinations of the data and identifications of domain patterns. Here is an example. So air sampling provides information on what was in the air over a period of typically the previous 24 hours. When daily samples are collected for several years, the data can be used to generate a pollen calendar for a specific geographic area. And these pollen calendars, however, cannot predict the severity of the pollen season. Exactly when the pollen season will start, how weather condition will affect the pollen release on a specific day, or if regional or long-distance sources contributed to the local pollen record. And here we can see a pollen calendar generated using observation. So days with different pollen concentrations were marked with different colors. We can easily notice that the high pollen concentrations occur on different days depending on the year in question. A similar calendar can be prepared for birch pollen, and the main limitation here is low predicting power, as we concentrate on the past instead of looking into the future. Here we have something more informative and attempt to put together the data from a period of 5 years. On this picture, the data are shown as discrete values. While here we can see something more, the probability density of the data, I mean the pollen count at different dates. Let us now focus on second type of models used in pollen forecasting, regression models. So let's start with the definition. So linear regression describes the relationships between a response variable of interest and one or more predictors, predictor variable, and multiple regressions is more sophisticated. It used to examine the relationship between several independent variables and a dependent variable. To illustrate this with an example, let's look at the result of multiple regressions carried out in order to find an equation explaining the start of the birch pollen season in Reykjavik. We can see that the onset of pollen can be forecasted using several predictors, such as precipitation in different months like March, December, February, mean temperature, and mean temperatures equal or higher than 5 degrees in March. And this particular model seems to be quite good, as its R-square value is well above 90%. Another example, predicting the start date of grass pollen season in Reykjavik, and again, R-square value is not bad, over 80%. But like everything, regression models have good and bad sides. Pros include simplicity and straightforward reasoning. But there are also some dark sides as well. So regression models are easily affected by outliers. They are limited to the linear relationship. And probably what is the most important, that time is fixed in regression models, which prevents any exploration of role of the time or of the role of the time scales. Now, a few words about the time series modeling. So, hypothetically speaking, the best way to deal with the time is the time series analysis. So what is the time series model? The time series models is a tool that analyzes historical data points to forecast future conditions and events. And the goal of it is to identify meaningful characteristics in the data that can be used in making statements about the future outcomes. Here we can see that there are different approaches to the problem of time series modeling, and not all methods fit all types of data. So there's like quite plenty of them. But when we analyzing a pollen time series, we needed to concentrate on the following questions. So when is pollen concentration typically highest or lowest? And how do pollen concentration vary with season of the year? What are the long-term trends in pollen concentration? What kind of seasonality are in pollen dataset? How do the time series data structure look like? How do pollen concentration compare with temperature and rain, and how has this changes over the time? And maybe not the last one, but the last one here. How do pollen concentration and temperature vary with seasons of the year? So here is an example of time series for total pollen concentration in Reykjavik during the more than 30 years. Each time series analysis starts with observations, and then different aspects of the data are taken into account, such as presence of trend, seasonality, and random noise. This analysis allows us to get an insight into the presence of seasonality in the data set and the presence of repeatable patterns. Here we can see an output of such time series model showing a part of input used for training and all test data used for validation. We'll come back to these results a bit later. Although time series have a lot of advantages, they also have a few disadvantages. So once a time-based series has been identified and established, the pattern and study may not always be easy or mathematically simple. Often it needs advanced statistical method to arrive at the realistic results. And what is like continuation of the previous point, time series methods draw on vastly different areas in statistics. And lately, even machine learning. You must know a lot about all these things in general to make sense of what you are doing. And what even more, there is no really unifications of the theory. So now a few words about artificial intelligence. So artificial intelligence is a collection of tools and techniques that can be used to let computers do challenging tasks. First attempts to use artificial intelligence data back to 1950s, but it was not until 2010 when artificial intelligence has experienced a time of rapid growth. So there is a wide variety of different algorithms that are classified under the name of artificial intelligence. But today I will mostly focus on the last point, on machine learning. So machine learning lies between both artificial intelligence and data science, and includes several types of algorithms. I will be talking today only about neural networks. So the neural networks is the kind of technology that is not an algorithm. It is a network, and that was weights on it. And you can adjust the weights so that it learns. There are many types of artificial neural networks that operate in different ways to achieve different outcomes. The most important thing about neural networks is that they are designed in a way that that is like how neuron in the brain works. And here is an example of an analysis I carried out just several days ago. And we can clearly see that these are just first steps, and a lot of work is still ahead. I hope that the next year I will be able to present some more decent results. Now I would like to move on the next part, which is the challenging art of pollen forecasting in Iceland. Let me go back to what I have already said about the pollen forecast. So producing a pollen forecast requires knowledge of the oncoming weather, as well as botanical aspect, such as the flowering stage of the various grasses and trees that produce pollen. Of course, we must realize that the situations we are currently in is not stable since climate change. And climate change is now causing allergy seasons to last longer, as rising temperatures are causing plants to bloom earlier. So pollen is on the move, with early blooming spores now wafting across traditional locales and into regions where those pollen species have typically bloom later, if at all, actually. I prepare a list of challenges on a way to a pollen forecast. So first of all, the pollen dataset is for sure typical intermittent time series. Of course, when pollen occurs, the concentration fluctuates a lot. In Iceland, we have only 2 monitoring stations. There is a lack of knowledge and studies on Icelandic people with allergy to pollen. Now, few points concerning weather. So the problem is with the level of forecast accuracy. As we all know, the weather in Iceland is very unstable during one day and from day to day, which is important because the weather affects the pollen concentrations. And my last point is long-scale pollen transport by the winds. But actually, the situation is not hopeless. Here we have plots showing concentration of birch pollen in Reykjavik during the last decade. One important thing to release here is the variability. There are no 2 identical seasons. The shape of the curve is not so regular, but rather something like this. And this ties in with the weather. There are several things to remember here. Pollen does not circulate as much during the rainy or windless days. And pollen tends to travel more during warm, dry, and windy weather. And during a stretch of cold and wet days, in general, the pollen level are typically lower. And although we all know that the weather has an impact on pollen concentration, this is the number doesn't show it so clearly. And this is mainly because of the huge variability of the weather conditions during the long summer days in Iceland. I think these graphs will perfectly show this. So here we can see the probability density of pollen concentrations and different values of maximum temperature during the day. It is easy to notice that the higher concentration tends to occur when the maximum temperature is relatively high. But for example, the differences between medium pollen concentration and high pollen concentration is not that clear. And now total precipitation and pollen concentration. A lot of outlier points make predictions a bit more difficult. Like here. And similar graph showing humidity level or maximum wind speed. If we look at the data really carefully, we can notice, for example, that the highest birch pollen at the beginning of the pollen season tend to occur when the winds are from north and eastern directions. To make a long story shorter, let me go back again to this graph. I divided the whole data set in two parts, training and testing set, and applied different time series models. So here we can see a forecast, like here. The main conclusion is that using combined results from several different models, we can predict pollen concentration with a reasonable accuracy. Here we can see results for 3 different models with predicted values compared to observed data. So we have like a profit model, random forest, and profit with some modifications. And for each model, we have 5 years. And we can see that there is quite a lot of days with successful forecasts, but each year's a bit different. This model is accurate for each year in different way. And finally, this is a graph showing a preliminary forecast for this season. So this is for 2021. I hope that from this season on, we will be able to deliver a forecast that could look like this, something like this, and include the following elements. So the forecast, pollen concentration, expressed as a low, medium or high concentration, a tendency, so growth, drop or no changes, and finally the main allergen present in the air. So for example, the birch. I would like to conclude this lecture with the words of my grandma, who used to say, Ewunia, take an umbrella with you, even if there is a good weather. So to paraphrase this word of wisdom from my grandmother, allergy sufferers should always have stuck up on tissue at times of pollen season. And that brings me to the end of my presentation. And I would like to thank you for your attention.
Thank you very much, Eva. And now we can start with questions. If there are any questions, please type them into the chat so that we can see them and answer. Yes, I already have one question here. The question is, what type of pollen will be included in the forecasts? What types of pollen?
Mainly two types. First is birch and grasses, because these two, for sure, these two types, because they are statistically important for us and important here in Iceland. Probably the other pollens which will be in a high level, like urtica or salix or rumex or I don't know, maybe ambrosia if they will be appear or something like that. But mainly these two types which are let's say danger for people with allergy here in Iceland, which level is statistically important, high, for people suffer high fever.
When the pollen forecasting will start?
I hope in April. So actually now we haven't snow yet, and the problem is probably some discuss the final version, how it should look like and where exactly should it be on the website on our institute or so. But I hope in this month or at least at the end or at the beginning of May, in my opinion.
Okay, thank you. And then the question is if the time series modeling can be also used for making predictions about things different than pollen, like for example predicting the growth of the populations of animals or something like that.
I don't think so. Actually, I mean each problem should have your own models. So we put actually we can, of course, we can use the same methods, statistical methods, but it will be looking different. And for animals, or it depends from the questions, from the problems which you have, and then we have to find a correct model. It could be the same like for the pollen, so we can use the time series using like I don't know Prophet or something like that, but it could be also something different. It depends from characteristics of the data actually which we have.
Okay.
Yeah.
I see no further questions, so I think I will ask Maria.
Pavel, there are two.
Yeah, there are two. Yeah, but I can't see them.
Yes, they're in the questions and answers. Ragnhildur Guðmundsdóttir is asking.
I'm coming.
You see it now. Okay.
Yeah. What software are you using for modeling?
So I use our program. And in case of this artificial intelligence, so neural networks, I'm preparing to use for Python. So it's like more programming than statistical compared to R.
Okay, and then we have a comment from Jon Gunnar. Congratulations, very interesting presentation.
Thank you.
I think now we have reached that all the questions have been. Oh, just one. Okay. Will the forecast be used for the summer?
I hope.
Yeah.
I would like. I think so. For this summer, yes, I think it will be.
Oh, it will be very good. Yes. Okay.
Okay. I think we have no further questions. So thank you, Pavel. And thank you, Eva Maria, very much.